All right, in this short video, we're going to take another look at an example where we're going to use Mr. McRae's Rule 1. If you are given a function and don't know what to do with it, put it in Y1. This particular question is coming from the January uh, 2016 exam, okay? And it says the graphs of y equals x squared minus 3 and the graphs of y equals 3x minus 4 intersect approximately where? Now, we had talked a bit about this before. Our intersection is where our line is going to cross. So based on Mr. McRae's rule, we're going to set the first equation equal to y1 and the second equation equal to y2. All right, and so in doing that, we're going to get our handy dandy graphing calculator here, and we're going to go to work. All right, so in this graphing calculator, what I'm going to do is I turn it on. All right, under y1, I'm going to plug in x squared minus 3. I'm going to slide down. I'm going to plug in 3x minus 4. Okay, and I'm going to hit zoom out because I want to make sure that I get a big enough picture to see the lines of intersection. Okay, wow, I see the line of intersection. Okay, so now I'm going to hit second trace 5. No, that's not what I want. Okay, remember, math means mistakes allow thinking to happen. Second trace, there we go, 5. I'm going to hit enter 3 times. 1, 2, 3. So according to this, I have one line of intersection that's happening at 0.38. All right. So that would mean that question 2, okay, line of, so x is 0.38, y is negative 285. Now, the question is this intersection only happening at this one place, or are there multiple points of intersection? Well, you know what? Let's let's see if we can change our picture so that we can get a little closer. So we're going to zoom in at this point. So let's zoom in, enter. Ah, so we do see that this graph is being intersected at 2 places. All right. So we saw this first intersection point. All right. But we didn't calculate the second intersection point. So here's what we're going to do. We're going to hit second trace 5. Now we want to focus on the second intersection point. So we're going to just use this slide button, slide over. All right. Okay, that's the first line. I'm going to enter. I'm going to look at the other line. Okay, so right here, I'm toggling back and forth between the Y1 and Y2. I really want the Y2. And, okay, so we got 2 points near that second intersection. And that second intersection is 0.38 when x is y, when x is 3.8 and y is negative 285. Okay. All right. So what did we determine? We determined the first point of intersection. What have we determined our second point of intersection? Again, we're going over 0.3. I got to rule out 0.385. So here's where I'm going to go. I'm going to scroll down here. 0.385. is somewhere over here. All right, and I'm gonna say that this seems a little out of bounds. I'm gonna try a different strategy. I'm gonna go to the table, second table. Okay, and because I want to see these endpoints, I'm going to say my table value. All right, I'm going to set my table value at let's say 0.25. Okay, then I'm going to go back to table, second table. All right, so I'm interested in what's the deal? What's the deal when X is 2.62 and 3.85? That's really what I'm looking for. So X is 2. Okay. So it looks like the 3.25 and 3.5, they're close. They're really close. All right, let's look for 3.85. All right, so we can rule out 3.85 altogether. So 4 is gone. Okay. All right, so really what we're looking at is 1 correct or is 3 correct. All right, and so here's what we're going to do to find out. What we're going to say is this. We're going to get out of graphing mode. I'm going to let X, I'm going to set 2.62. That's what we have in question. I'm going to store that under the X key, X value. And then I'm going to type in this equation and see if I get and see if I get 3.85 back. So let's see. X squared, slide to the right, -3 equals, I got 3.86 back. It's pretty close. All right, let's put in the second value. 3x, this is the value from over here on the right, -4, 386. So I can pretty much say with kind of certainty that 3 is the correct answer. All right, I hope this little video, which went a little longer than I wanted to, helps out.